Welcome back to the GCSE Maths Pro YouTube channel. Today's video is going to be a summary of all the parts of algebraic fractions. So that means we'll be looking at how to simplify algebraic fractions, how to express them as a single fraction when you're given multiple, if you need to add, subtract, multiply or divide them, and finally how to solve equations when we've got algebraic fractions. This topic is mainly for higher tier only. If you would like to see any of the full videos for each of these three parts, they will be linked in the description down below.
Okay, so these are most likely to be the fractions you're actually going to see. These are the slightly harder ones where you can clearly see we've got two quadratics, the top and the bottom of the fraction, and it says simplify, which immediately looks pretty scary because you might think, oh, what do you mean simplify? There's so much going on here. But also don't start getting confused and think, oh, I can cancel out the x squares because there's some there. I can cancel out maybe the x's. No, again, think about what we've just been going through. You can only cancel something out of a fraction, or an algebraic fraction in this case, if all of the terms in all of the fraction have it. There are 6 terms here currently. They don't all have x squared in them, so I cannot cancel out x squared, for example. So again, just think, if I'm simplifying algebraic fractions, I need to factorise. Whether that's into single brackets or double brackets, it just depends on the question. In this case, they're both full quadratics, so it's likely to be into double brackets, the top and the bottom. If you want to go over factorising quadratics, I will link the videos down below and here as well. I'm just going to whiz through it really quickly, but you do need to know that skill not just for questions on factorising quadratics, but in this case where we are basically within the topic of algebraic fractions needing to also factorise. So the top one, we've got obviously x and x because it's just x squared. We're timesing to make a positive, adding to make a positive, everything is positive. Timesing to make 20, adding to make 9, so I'm going to do 4 and 5. The denominator, again, we've got x and x. Timesing, in this case, to make a negative, so I know I need a plus and a minus. We're timesing to make 60, but when I add them, it makes minus 7. The other thing is that once I've done the top one of those two brackets must also be the same as one of the bottom ones. So that does help me narrow down my options. Factors of 60 that would make 7, I can go with 5 and 12, specifically plus 5, minus 12. Now, do you see how, because everything is multiplied, technically brackets like this means multiplied, isn't it? That means I can now imagine my numerator as one whole number and my denominator as another one whole term and another whole term. Because they're not added or subtracted anymore like we had up here, they are multiplied, which means these are factors of each other. So if they both have the factor x plus 5, or they're both multiplied by x plus 5, that means it's a factor, isn't it? It means they have it in common as a factor. So when I'm simplifying, I can just cancel both of these out. So then I'm left with just numerator, x plus 4, I don't need the brackets anymore because there's only that one left, and x minus 12 in the denominator. Again, don't start thinking, oh, I can cancel out the x's and such. Remember, it has to be common in all of the terms. Now I've gone back to having pluses and minuses. Nothing is multiplied, is it? So x is not a common factor between all 4 terms here. So when you're simplifying algebraic fractions where you've got quadratics, you want to factorise the top and the bottom as much as you can, and then cancel out any of the brackets that are exactly the same. It has to be the same symbol, same number, everything. So that's your final answer. Okay, quite a common one that they do as well is, well, first of all, the numerator is a harder quadratic. We've got 2x squared, not just x squared, so you have to factorise a harder quadratic. But also the denominator looks a bit different. It doesn't have all 3 terms that a normal quadratic would. So this is a separate topic, but it comes up a lot in algebraic fractions. The numerator obviously factorises into 2 brackets because it's a full quadratic. The denominator does also factorise into 2 brackets. You might be thinking, no, it's only going to be 1 bracket because it's not a full quadratic, but there will be nothing in common to pull out, would there, to be put on the outside. So the bottom one is actually called the difference of 2 squares. X squared is a square number, 9 is a square number, and minus means difference. So we're still going to have x and x. Because we're timesing to make the 9, that's still the number at the end, isn't it? We've got plus and a minus to make a negative. And then technically it's kind of like this, x squared plus 0x minus 9, isn't it? We just obviously don't need to write 0x. What 2 numbers would multiply to make 9? But would actually, when you add them, cancel out, make 0? Well, obviously 3 and 3, difference of 2 squares. Now that I've done that, that's actually going to hint to me that the numerator must also have a bracket with either x plus 3 or x minus 3. So factorising the numerator, we're timesing to make minus 3, adding to make minus 5. Although because it's 2x squared, I'm going to have 2x and x. Timesing to make 3 is 1 and 3. Now, this is where I'll come back to what we've already worked out. I know I need to have a bracket with either x plus 3 or x minus 3, not 2x, so I know that it would have to go that way around, wouldn't it? That would help me kind of make that assumption. The only thing is I now need to figure out the plus and the minus. Adding to make minus 5, so yeah, minus 3 would make 2 times minus 3 is minus 6, plus 1 is minus 5. And now I can cancel out the two brackets that are the same, x minus 3. These ones are normally a few marks. You might think that you haven't actually done that many steps, but it's because we did quite a lot of factorising all in one step. So yeah, that is the final answer. There's still quite a lot there. We still have 4 terms, but again, there's nothing that I can simplify. There are no common factors between all of these terms. I cannot just take an x and an x like that, because it's not that all of the terms have x's, it's only half of the terms. X is not a common factor of all of them, for example. So that is the most simplified answer. So, for example, we might have a variety of different operations in terms of maybe multiplication, adding, subtracting, division, and we're just literally asked to rewrite it in the form of a single fraction. So the first one we have express 4x minus 10 over 8 times 2 over 3x plus 6 as a single fraction and in its simplest form. So the first thing I'm going to do is not really worry about the fact that I need to express it as a single fraction. I'm just going to actually apply whatever operation is happening. In this case, it's multiply. So multiplying fractions is actually quite easy. We just have to times across horizontally. So the two numerators you multiply, the two denominators I multiply. Obviously, you might be happy to just multiply that directly, but I'm just going to write it out fully as it's going to be a set of single brackets, just so you can really see it properly. And the denominator is 8 multiplied by 3x plus 6. Now I can literally expand out these brackets. So we get at the top 8x, then we get minus 20, and the bottom we get 24x, and then plus 48. Okay, so we have already obviously got it as a single fraction, but that's why they've also specified in the simplest form. I'm now going to look at this and see if I can simplify it. What I'm looking for is, you see how I have 4 terms here? I've got 8x, minus 20, 24x, and 48. I need to find or see if there is a common factor between all 4 of those terms. Is there a number that I can divide all 4 of those terms by? And actually, yes, the highest common factor of all 4 would be 4. So I'm going to divide each of these 4 terms by 4. The other way that we did in the previous one was factorising out a 4. You could write it like this if you want. So I get 2x minus 5. And then at the bottom, if I factorise out 4, I get 6x plus 12. Now, you don't necessarily have to write it like that. You can just literally work out what it is without the 4s, but I'm just doing it to kind of over-explain it for you. And as you can see, I can then cross out both of the 4s, they cancel out. So there's my final answer, basically. We get 2x minus 5 at the top, and 6x plus 12 at the bottom. It feels like I should be able to simplify it more, maybe by 2, but as you can see, the 5, I can't divide 5 by 2. The other 3 terms I can, but not the 5, so therefore that's it. That's the most simplified I can get. I've got 2x minus 5 over 6x plus 12. Okay, so now we have a subtract one, but not only do we have one fraction and then an actual whole number, minus 1. So express 2x minus 1 over x plus 9 and then minus 1 as a single fraction. So how do I incorporate a whole number into a fraction? Well, what I would do is, because we know when we subtract fractions, we know how to do that, I would make that 1, first of all, into a fraction. Any whole number, if you want to make it into a fraction, you just put it over 1. I know 1 over 1 is kind of looks stupid, but yeah, that's still the same as 1, isn't it? If I did 1 divided by 1, I still get 1. But I'm kind of reversing it. I want to make it into a fraction. So if you have a whole number, just put that number divided by 1. That's the fraction. Now, obviously, I know that I do need to have common denominators, though. So if I multiply together those denominators, I actually obviously just get x plus 9, don't I? X plus 9 times 1 is x plus 9. So that first fraction can stay the same, luckily. Minus the second fraction, I need to make it x plus 9 as the denominator. So I'm going to times the bottom by x plus 9, times the top by x plus 9. Because it was 1, obviously it's just 1 times x plus 9 is x plus 9. So I've now converted this. Originally it was a 1, now it's this fraction. That's still 1, because if I were to simplify that, x plus 9 divided by itself is still 1, isn't it? Now we can carry on as we did with the previous questions, just subtract the numerators this time. Remember, we're subtracting. So I would probably write it like this: 2x minus 1, subtract, and then put the other one in brackets, because I don't want you to forget. Obviously, it's quite easy to go, yeah, I need to subtract the x, but don't add the 9. We're actually subtracting 9, aren't we, as well? So I tend to write it in brackets just for that step there, so I don't forget to subtract not only the x, but also the 9. So now I'm going to subtract. So 2x minus x is obviously just like 1x. Minus 1, take away 9, is then minus 10. Okay? Minus 10. We're not adding the 9, we're taking it away. And then it's over x plus 9. You check, can I simplify this fraction at all? No, there's no common factors between all 4 terms. So that is just it. That's my answer. I've incorporated the 1 as a whole number into that fraction. Okay, very similar one again, just a bit longer basically. So I'm going to deal with this in exactly the same way as I just said. So we've got express 2x squared minus 7x minus 4 over 6x squared plus 13x plus 5 divided by x cubed minus 2x squared minus 8x over 3x plus 5 as a single fraction. The other thing you might have noticed is we've got an x cubed. So you might be thinking, how am I supposed to factorise that? I don't know how to factorise anything but quadratics. We'll look at that in a second. Let's just go through one at a time. So I'm going to try and factorise everything that can possibly be factorised, basically. Again, if you want to go through how to factorise quadratics, then I'll link the videos down below as well, so you can recap that. So the numerator, we've got 2x plus 1, x minus 4. Denominator, we've got 3x plus 5, 2x plus 1. Then divide by the second fraction. Now the denominator can't be factorised, so that's fine. The numerator, however, yeah, again, you might be thinking, I don't know how to factorise a cubic expression. That's fine. We're not going to be using 3 brackets. Can you see how all 3 terms have x? So actually, in this case, and this is what often happens with GCSE, if you do see something with x cubed and you need to factorise it, a lot of the time it's just pulling out an x. So if I pull out the x, you see how I then get left with x squared minus 2x minus 8. So actually it is just a quadratic, but they've multiplied it by x. Then this quadratic I can now factorise into 2 brackets. So I'm just going to write it here again. So we've got x and x, plus and a minus. There we go. X plus 2, x minus 4, and then just an x on the outside. So I factorised everything. Check, can I already cancel anything out? Well, in the first fraction I can. 2x plus 1, so that simplifies. So I'm going to rewrite that first fraction. I'm going to now apply my divide to bring together both fractions. So my first fraction is now x minus 4 over 3x plus 5. Keep flip change, so that becomes multiply. We get 3x plus 5 at the top now. Then x brackets x plus 2, x minus 4 on the bottom. And multiplying straight across, again, don't expand anything, just leave it all in brackets. So the numerator will be x minus 4 brackets 3x plus 5 over, just leave that x at the front there, 3x plus 5 in a bracket, x plus 2 still in a bracket, and the other x minus 4 still in a bracket. Okay, can I cancel out any of the other brackets now? Yes, we've got x minus 4. We've also got 3x plus 5. Now, we've cancelled out the whole of the numerator, so a lot of people would think, oh yeah, it's just whatever's left in the denominator. But remember, those are still in the denominator, okay? So even though I've cancelled stuff out of the numerator, I still have to have a 1 there. It doesn't just disappear. If it were the other way around, if I cancelled out the denominator, then yeah, there's no fraction anymore, is there? But I am still dividing something by x brackets x plus 2. So it's actually 1 at the top there that's left, okay? In this case, that's my answer. I'm not going to bother expanding it, just leave it like that. We've got 1 over x brackets x plus 2. That's the most simplified I can get. So we've got solve 2x plus 1 over 6 plus x plus 5 over 2 equals x plus 4 over 3. There's a few ways to do this, again, different orders that you can do things in. If you wanted, you could just add these two together first to get a single fraction. But what I'm thinking is I just want to cancel out all the denominators straight away. In this particular case, it might not always be the case, but in this case, can you see how 6, 2 and 3 is the denominators? 2 and 3 are factors of 6, aren't they? So I'm actually going to choose to multiply by the biggest number. I'm going to times everything by 6. Now just be careful here. I know I've written it down twice, but I do need to times all 3 parts, all 3 terms I guess you could call it, by 6. So the first fraction will just open up and become 2x plus 1 because I'm cancelling out the 6. The second fraction, I still need to multiply by 6 though, because it wasn't divided by 6. I need to still multiply by 6. So I'm going to put 6 in the numerator. When you're multiplying by a whole number, when you're multiplying any fraction, whether it's algebraic or just a normal fraction, if you multiply it by a whole number, you're just affecting the numerator. So the denominator is still 2, because technically 6 is 6 over 1. So that's how I'm only affecting the numerator. And then, again, obviously I need to multiply the right-hand side. So again, I'll put 6 as a bracket there, x plus 4 over 3. If I now look at these two other fractions, do you see how because I had 2 and 3 as factors of 6, 6 divided by 2 is just 3, isn't it? So that one just cancels out the denominator naturally, but obviously I still have to multiply everything then by 3 instead of 6. Same with this second one. 6 divided by 3 is 2. So that one just gets multiplied by 2. That's why I chose the biggest denominator. Now this only works if the other two denominators are factors of that number. In the case that you might get, it might not be, so you might have to multiply by all of the denominators individually, one at a time. You might have to do that, but in this case we didn't have to. Now I've got rid of all my algebraic fractions, I'm just going to expand and simplify and collect any of the like terms. So we've got 2x plus 1 plus 3x plus 15 equals 2x plus 8. I want to bring all the x's together, so we've got 5x plus 16 equals 2x plus 8. I'm going to move the smaller number to the left so that I have a positive amount of x's. So I'm going to take away 2x, so I get 3x. And at the same time, I'm going to subtract 16. So 8 take away 16 is minus 8. And finally, bring it over here. We obviously then divide by 3, don't we? So we get x equals minus 8 over 3. Okay, just leave it as a fraction because that's a recurring decimal and I don't really want to work it out. So I'm going to leave it as a fraction, that's absolutely fine. Okay, so this one, we have got something added together. The denominators are where the x's are, but we've also got this equals 1 bit. So, again, there's 2 ways to do this. If you would like, you can add these together. So we saw this in the previous video, where we were saying express as a single fraction. We would have to find common denominators and add them, and then we can deal with getting rid of the fraction. Or, we can just get rid of these fractions straight away, as we've kind of done in that previous question. So it's completely up to you what you prefer to do. I'm just going to get rid of the fractions, because I don't think there's any point in adding them and then having to get rid of the fractions. So I need to times by each denominator. So I'm just picking the first denominator basically in this case because there's not really much difference. Doesn't matter which one you pick first, I'm just going to go with the one that has come up initially. So multiplying by x minus 5, obviously that cancels out that denominator there, so I'm left with just 2. However, this second fraction didn't have x minus 5. So I'm not cancelling out, so if I'm timesing by x minus 5, it will actually have an effect. I do need to still multiply that by x minus 5. It goes in the numerator. And obviously 1 times x minus 5 is just x minus 5. Now I still have one more denominator to get rid of, so I'm going to times now everything by x. Again, remember, all 3 terms need to be multiplied by x, so we've got 2x plus, now this one just opens up to be just the numerator there, because that obviously cancels out that x, equals, and then x times x minus 5. So now we've got rid of all of the fractions. Now it's just a case of expanding and rearranging. So we've got 2x plus 6x minus 30 equals x squared minus 5x. So because we've got an x squared again, it's a quadratic, we know that we're going to need to get everything on one side and hopefully see if we can factorise. I'm going to move everything to the side where the x squared is positive, so in this case I'm going to move all of this to the right hand side. First of all though, I can add together 2x and 6x, and then I'll move everything. So let's bring it up here. 0 on the left, we've got x squared. Minus 5x, take away another 8x is minus 13x. And then we're going to need to add the 30. There we go. Now this quadratic I can't simplify any further, that's just as far as it goes, so I'm going to straight away go into factorising. X and an x, I need two negatives. Numbers that times to make 30 add to make 13 is obviously 3 and 10. And my solutions are x is 3 or 10. And there we go. That's it solved. Okay, this is our last question. As you can see, there's a little bit more to it. It does look similar to the previous one in the fact that it says solve 1 over x plus 4 plus 2 over x plus 11 equals 1. That's very similar. But we also have this added information where it says give your answer in the form p plus or minus root q, where p and q are integers. So this will likely be towards the end of your paper. It might be quite a few marks, it might be 4 marks, maybe even 5. But all of these things are giving me hints as to how I'm going to solve this. Obviously, I'm still going to do the same thing where I'm going to multiply by those denominators to cancel them out, but it's given me a hint as to where it's going to lead. Having a surd like this and a plus or minus is hinting to the fact that I'm going to get a quadratic, because plus or minus means 2 solutions, but that I'm going to get a quadratic that I cannot factorise like we've just done with the previous 2 questions. So that's just a heads up there. Let's just carry on as we were before. I'm going to multiply across by the first denominator. So timesing by x plus 4 first of all. Again, remember to times all 3 terms. So the first term will obviously just cancel it out, so we get left with 1. The 1 doesn't disappear, it's still there. Plus 2, we need to times that 1 by x plus 4, so that goes in the numerator. Still over x plus 11. And then 1 at the end times by x plus 4 is obviously just then x plus 4. Now, times by that other denominator, which is x plus 11. Again, remember to times all 3 terms by x plus 11. So 1 times x plus 11 is obviously x plus 11. This one, it will just cancel out the denominator, so we're left with 2 brackets x plus 4. And then the right hand side, we've got double brackets. That's where our quadratic is coming from. Now I've got rid of my fractions, I'm just going to expand everything. So x plus 11 plus 2x plus 8 equals x squared plus 11x plus 4x plus 44. Now we're going to come over here, collect all the like terms. So 3x plus 19 is x squared plus 15x plus 44. Because it's a quadratic, I do still need to get everything on one side. Now move it to where the x squared is positive, so I'm going to move everything to the right hand side in this case. So we get 0 equals x squared, 15x take away 3x is 12x, and 44 take away 19 is 25. Now, you could try and factorise that, because normally with quadratics we do try and factorise first, don't we? But because they've told me this, I already know that I can't factorise it. I'm not going to get a root. Like, if I can factorise, they should all be whole numbers. Where does this root come from? So I know I can't factorise. So you've got 2 options. I guess it depends if it's a calculator question or not. If it's a calculator question, this is hinting to me to use the quadratic formula. You can use the quadratic formula either way, to be fair. The other option is you could complete the square and then solve it that way. I feel like that might be going around the houses though, so it's completely up to you. There's different ways of doing things. As long as you get the same answer, you'll get the marks. So yeah, let's use the quadratic formula, which should be on your formula sheet, but I'll write it here anyway. Okay, so the quadratic formula works in the way that a, b and c, as long as you've written it in order, so x squared first, so a is technically 1, b is then 12, and c is 25. All of them are positive. If they were negatives, you'd have to go with that as well. So we've got x equals minus b, so minus 12, plus or minus the square root of 12 squared, minus 4 times a is just 1, so that really makes no difference, times 25, over 2 times 1, again, doesn't really make any difference. And then I would just simplify each of these parts. Again, we're not going to be working out the square root as such, just the pieces in between. So we've got minus 12, plus or minus 12 squared is 144, take away 4 times 25 is 100, over 2 times 1 is obviously 2. Okay, I've just moved everything over so we've got some more space. So that should give me minus 12 plus or minus root 44. over 2. Obviously 44 is not a square number because we're expecting to be left with a root, but that's fine. Sometimes this then includes some surds, doesn't it? So let's see, can I simplify root 44 as a surd? Are there any square numbers that go into 44? Well, yeah, 4, right? So root 4, root 11 over 2. Then I can actually square root the 4, so that becomes 2 root 11 over 2. Now finally, I'm just going to simplify the fraction. I've got 3 terms here. I've got minus 12, I've got 2 root 11, and 2. The root 11 part is irrelevant because that's a surd, but looking at just the whole numbers, minus 12, 2 and 2, they're all divisible by 2, so I can actually divide that. The other thing is that, do you see how my answer they've given me as the format is not a fraction? So I know that it should cancel out as a fraction as well. So I get minus 6 plus or minus root 11. And that's x. My two solutions is the fact that I've got minus 6 plus root 11 and minus 6 minus root 11. Those are the two solutions from our quadratic. But yeah, sometimes you might be left with this format. So I can actually use quadratic formula when I don't have a calculator. Obviously, if you had a calculator, type it all in at this point, and then it should simplify it for you. But make sure you leave it in the surd form.
So thanks for watching this video. Again, this was a summary of the whole topic of algebraic fractions, so that is everything you'll need to know. If you would like to look at any more questions or go through these videos in more detail, the links will be down below in the description for each individual full video.